everyone, welcome to a little video about target 4C. All right, let's get started. Exponential growth. So exponential growth looks like this as a function. F of x equals a, parenthesis 1 plus r to the power of x. Now a is our initial value, so whatever we're starting with, when it depends on the problem, and r is our rate. And sometimes this comes as a percent, and we always need to change it back into a decimal. Now, the key thing about growth is to recognize that whatever is inside those parentheses is greater than 1, because that's growing. Exponential decay is kind of similar. Still starts with f of x, because it's a function. Still starts with a for our initial value. Still has a 1, but because this is decay, it's decreasing. So 1 minus r to the power of x. And r is still rate. Remember, it's going to be in a decimal form. And this just has to be less than 1. And that's what makes it decay. So based on that, let's take a look at number 1 and decide whether or not all of these are exponential growth or decay. Number 1, we have addition. That's an easy thing to see. Once we see a plus sign, automatically growth. Similarly to letter B, once we see a minus sign, we can automatically say decay because it's decreasing. Now, in letter C, it's a little less obvious, but we do have a decimal that starts with a 0. And a decimal that starts with a 0 means it's less than 1, which makes it a decay function. Next, we have letter D, also a little less obvious because we have no addition or subtraction. We just have 1.32. But 1.32 is greater than 1, therefore it's growth. Letter E, we have subtraction going on, so right away we can say that's decay. Letter F, we don't have addition or subtraction, but our decimal is less than 1, therefore decay. Now what we're going to do for number 2 is we're just going to write the function for it. We're not going to solve it because we have nothing to solve for. All right, so number 2, this is how it starts. A new car we bought for $25,000 decreases in value 15% each year. All right, so we have our function. We begin with our initial, so that's $25,000. And then since we're decreasing, we're going to have 1 minus. Now this is the most important part. We're going to take this 15%. In order to make it into a decimal, you're going to do 15 divided by 100. So that's 0.15. So a percent symbol represents that division by 100. So it's not an actual number. You can't put in 15 for 15%. That would be incorrect. All right. Now, it is a little bit more traditional to go ahead and simplify it a little bit more. So the only thing I can actually simplify is what's inside those parentheses. So this becomes 25,000, and then 1 minus 0.15 is 0.85. So it just looks a little nicer to the power of x. And that's it. Let's do the same thing for letter B. Letter B, a baseball card we bought for $15,000. Sorry, for $5,000. Oh, it was an expensive card. So we begin with 5,000. It increases, so plus 5% each year. 5% as a decimal is 0.05. If you're ever unsure, use your calculator. You can even do this on your phone. You can do 5 divided by 100, and it gives you a nice decimal. So it'll always give you the right thing if you ever doubt yourself. All right, to the power of x, I'm going to simplify just a teensy-weensy bit and do 1 plus 0.5 is 1.05 to the power of x. Letter C, a population of ants starts at 30. Okay, so that's our initial value, 30. And increases by 50% each year. So that's 1 plus for increasing. 50% is 0.5 to the power of x. Well, let's simplify a tiny bit. Perfect. Letter D. Your heart rate reaches 140 beats per minute and then decreases by 40% each minute. So our initial heartbeat is 140. Since we're decreasing, we're subtracting, and 40 as a decimal is 0.4. Let's simplify that a teeny bit. That becomes 0.6. You can leave it as a subtraction problem in the parentheses. It just looks a little nicer when you simplify it. And lastly, letter E, we still have our heart rate starting at 140, but then we increase it by 40%. So plus. Now I hope we don't increase it too much. That's not good. That'll lead to a heart attack. But that's fine. All I did here to simplify it is I did 1 plus 0.4, which gave me 1.4. Oh, okay, so now we're going to get to more real life stuff. I love this. So what we're going to be doing like a compound interest, and this is the compound interest formula. Now it's very similar to the one we just saw. A is going to be our total amount. P is our initial. 1 plus R, still have rate, to the power of T for time. So A would be your final amount, so total. P is initial, so similarly to how A was, it's just P now. R is still our rate, and T is time. Now time can be in any like amount of values. So like if you have time in minutes, your answer is going to be about minutes. If your time is in years or hours, it's going to be about years or hours. So it doesn't really matter which unit the time is in, as long as that's where you're putting the amount of time. And if you're ever asked to, analyze the problem, you are, saying years, minutes, hours, etc., whatever it's about. Okay, so we are considering depositing $300 into an account that pays compound interest. How much will there be in an account if you receive 6% interest over 5 years? All right, let's do it. So we have 300 that we start off with, and then 1 plus 6% as a rate, is a decimal, is 0.06. And 5 for years. All right. And color coding, because I love it. Because I love it. All right, so here's our, whoops. I think I deleted my highlighter by accident. I got so excited. All right, there we go. Blue. Rate is 6%, and our initial value is 300. This is going to be a little disappointing, but this is pretty accurate. After keeping it in the bank for 5 years, you only end up, if you don't touch that money at all, $401.47. So yes, savings accounts are great and it's good to put away money, but just keep in mind that it's not really going to grow as much unless you invest your money in something. All right, number 4, a population of ants starts with 50. All right, so we start with 50. How many ants will there be after 3 years if we increase by 4.3%? All right, so our rate as a decimal is 0.043, and we're going for 3 years. All right, let's do some coding. 50 is our initial amount, our rate as a decimal, and our time, our time in years. Right, when I put that into my calculator, I got 56.73. This is a living being, so it's just 56 ants. Let's not, you always want to round down with that. Number 5, we're considering depositing 1,000 into account. All right, not bad. It pays compound interest, but only 1.5%. That's tiny. And we're keeping it in there for 10 years. We're not going to touch it. Oof. Okay. So it's not going to be a great big amount either this time, because that is a tiny percent. Jeez Louise. All right. Plopping that into my calculator, we get only $1,160.54 after 10 years. Yikes. All right, number 6, we're considering depositing $2,500. Okay, it's a little better. And how much are we going to pay in interest? How much are we going to receive in interest? We're going to receive 2.3%. Okay, that's a little better. As a decimal, 2.3% is 0.023. And we're keeping it for 15 years. Oh my. That's going to be a hard time to not just touch that money. But, this is in the world of our imagination, so that's all fine and dandy. 15 years. Plug it into your calculator. We end up with $3,516.21. Whoops. No whoops. I don't know why I said whoops. And 21 cents. Okay? Not that much. And lastly, number 7. We have a starting amount of 500. Okay, not bad either. This is a little bit more realistic for your age, I think, if you're listening to me at high school age. We receive 9.1%. Ooh, this is an imaginary bank for 10 years. Um, uh, that's going to be very hard to find. I don't even know if that's possible to find an interest like that. That's really nice. All right, let's plug it into our calculator. After 10 years, we only end up just a little over doubling our money. Okay. I hope this was helpful. If you have any questions, please feel free to ask me or your teacher. Otherwise, have a wonderful rest of your day. Bye.